Here's the third out of the 5 FRQs for polar. Here we go. So we have this curve here. They give us a picture, which is great. We don't have to graph it on our own. We have r equals theta plus sine 2 theta. They even give us a bound, which is awesome. The derivative, they even give us the derivative here. Okay, so part A. Find the area bounded by the curve in the x-axis. So pretty much everything in here. So this is super easy because it's 1/2. There's only one function here, so it'll be theta plus sine 2 theta squared, d theta. And they even give you the bounds, 0 to pi. That's a quick plug and chug, whatever that comes out to there, okay? Here's part B. Find the angle theta that corresponds to the point of the curve with x coordinate -2. This is kind of like that last FRQ, okay? Remember that x is equal to r cosine theta. So we know that the x coordinate is -2. We know that r is theta plus 2 sine 2 theta cosine theta. So notice how the only missing variable we have here is theta. So what we're going to do is we're going to use our calculator again. And we're going to go ahead and find our intersection point. I would let y1 equal this and y2 equal all of that there, okay? So let's see. We have -2. The quantity of x plus 2 sine 2x times the cosine of x. Okay, and I'm going to make sure that I go from 0 to pi here. So I'm going to go ahead and change my window from 0 to pi for the x min and the x max. And I'm looking for an intersection point. So just to give you an idea, if you're on the right page, I have something that looks like this and like something like that, but the intersection point is right there, okay? So we're going to go to second, trace, 5, enter, and since there's only one intersection, I can press enter again. And the intersection point looks like it's at 2.918 if you round correctly. Okay, that's all they asked for part B. Okay, let's keep going. Part C. Okay, so for part C, they're saying from pi over 3 to 2 pi over 3, the derivative dr d theta is negative. So that looks like it'll play an important role, okay? What does this fact say about r, and what does that say about the curve? Okay, so somewhere in between pi over 3 and 2 pi over 3. Okay, so there's a lot of analysis to this. So let me write this down so that you guys can understand this. We know r, and we know that from pi over 3 all the way to 2 pi over 3, dr d theta is negative. Okay? The only thing missing here is, well, what's happening with r? Is r greater than 0 or less than 0, right? And this is where you actually have to analyze this. If you pick any angle in here, pi over 3 to 2 pi over 3, that's somewhere in between quadrants 1 and 2. So you know sine will always come out positive there. So that means you're adding positives with more positives. So that would imply that r is greater than 0. Okay? So if r is greater than 0, okay? So let me just draw something here. Let's say that r is greater than 0. Okay, so you're somewhere in the first or second quadrant. And if dr d theta is less than 0, that means r is decreasing, meaning that whether you're in the second or the first quadrant, notice how you're going to head towards the origin. So I won't write it down, but towards the origin. Okay. What does this fact say about the curve? Isn't that what it says about the curve? Okay, so this will say that R is decreasing, and the curve means that the curve is heading towards the origin. I think that's what they're asking for. Let me check. Okay, R is decreasing, curve is getting closer to the origin. Perfect. Okay. A little bit more space for part D. Okay, find the value of theta somewhere between 0 and pi over 2 that corresponds to the point on the curve in the first quadrant with greatest distance from the origin. So if you're comparing something from the origin, you're looking at the r, the radius, okay? And greatest distance is another word for maximum distance. So we're actually looking for a maximum here, specifically an absolute maximum because it's a closed interval. We kind of did this back in AB. So it's been a while. So when it's an absolute max, what we want to do is we want to create a table. Absolute maximums can occur at the endpoints, so 0 and pi over 2, and wherever the derivative is equal to 0, okay? So let me, we have the derivative here. We're going to set it equal to 0. And I'm just going to go ahead and, you can do that by hand, but I'll cheat a little bit. I'll just use a calculator. What I'm doing is I'm going to y equals, and I'm typing y1 as 1 plus 2 cosine 2 theta, 2x. And I'm going to go ahead and hit graph from 0 to pi over 2. So x min will be 0, x max will be pi over 2. And I'm looking for where it crosses the x-axis because those are my zeros, okay? And it looks like it's crossing right at 1, but let me just double check. Second trace 2 for 0. Pick a good left and right bound. It's looking like 1.047. That's what I got. Let me double check the table down here. Pi over 3, which is 1.047-ish, okay? So what we're going to do is we're going to try to find the furthest distance. So we're comparing it to r here, okay? So what you're going to do is there's a lot of plug and chug here. But basically you're plugging in these 3 different values into r. And I'm just going to cheat a little bit here because I don't want a number crunch. Basically you get these 3 values here. The one with the greatest distance is obviously this one here. So they ask you specifically not what the greatest distance is, but find the value of theta at where it occurs. So it occurs at pi over 3. Okay, that one definitely is the outlier there. Parts A, B, and C are a little bit more common. But there you have it.